Have you ever looked at two processes with the same average, but one feels way more unstable than the other? Maybe two machines produce parts with the same mean thickness, but one keeps triggering rework. That's the power of variation. And to measure variation, we've got three main tools in our Six Sigma toolkit: range, variance, and standard deviation. In this video, I'll show you what they mean, when to use each one, and how to decide which one gives you the real story about your process. Part 1. Range, the simplest measure. Let's start simple, with range. The range is just the difference between the highest and the lowest value in your dataset. Example: imagine you measured coating thickness 5 times, and these are the thicknesses you measured: 9.8, 10.0, 10.1, 9.7, 10.2. Range is equal 10.2 minus 9.7 equal 0.5. When to use range. Quick checks. Early stages of a process study. When you want a snapshot of variation. Especially useful in control charts like the R chart during short-term analysis. What about the limitations? It only looks at the two extreme points. If one measurement is way off, the range can exaggerate variation. So it's simple, but not reliable for long-term analysis. Now let's get a bit deeper. Variance. Variance tells us how far each data point is from the mean on average. It's the average of the squared differences from the mean. For example, using the same dataset, 9.8, 10.0, 10.1, 9.7, 10.2. Mean is 9.96. Variance is average of square root of each value minus mean, approximately 0.033. When to use variance. When comparing two datasets mathematically, like during ANOVA. When building models or doing statistical analysis. Behind the scenes in many Six Sigma tools, like F-test or regression. Limitation. Variance is in squared units. If you're measuring in millimeters, variance is in millimeters squared. Not intuitive for explaining to your team or management. That's where the next metric comes in. Part 3. Standard deviation, the practical measure. The standard deviation is simply the square root of the variance. That brings the number back to the same unit as your measurement, so it's easier to interpret. In our example, variance equals 0.033, standard deviation equals square root of 0.033 equals 0.18. When to use standard deviation. To understand how consistent your process is, used in process capability, CP/CPK, calculations, used in control charts, X-bar, to track process stability, to compare the spread of different datasets that have the same mean. Interpretation tip. In a normal distribution, 68% of data falls within ±1, 95% within ±2 sigma, 99.7% within ±3 sigma. So if your process mean is 10 millimeters and sigma equals 0.1, 95% of your parts fall between 9.8 and 10.2 millimeters. That's a predictable, stable process, every Six Sigma engineer's dream. Part 4. When to use each. Let's summarize this visually. Quick rule of thumb. Use range for quick shop floor checks. Use standard deviation for reports, SPC charts, and Six Sigma analysis. Use variance when doing deeper statistical modeling or hypothesis testing. Part 5. Why this matters. In Lean Six Sigma, we say, you can't improve what you don't measure. Measuring variation is how we separate common cause noise from special cause signals. The smaller your standard deviation, the more predictable and capable your process is. That's what makes range, variance, and standard deviation not just numbers, but the foundation of process excellence. So next time someone says, "Our average is fine," ask them, "What's the variation?" Because consistency beats averages every single time. If you found this helpful, give it a thumbs up, subscribe to InfiniLean, and check the link below for my full Six Sigma statistics playlist, where I explain these concepts in simple, real-world examples.